Okay guys, welcome back. So in the last video I explained to you about the different types of forces and how two forces can be equal and about the moment of a force. Another important characteristic of a particular type of force is the resultant of force. Now you know what is meant by the resultant of a force. I explained you about a general introduction in the case of vectors and the introduction to physics. Those videos, if you are not watched that videos, I invite you to watch. In any case, I'll explain you about a brief introduction about these concepts. Alright, so a resultant force. What is a resultant force? A resultant force is any single force which can replace a set of forces. So if you take this system of forces, now for example, if you consider this system and this system, so in this system I have given a force of 3 Newton in this direction, a force of 4 Newtons in this direction, and a force of 8 Newtons in this direction. So if the mass of this object is m and the acceleration of this object is a due to these three forces, you can say that 3 is equal to ma from Newton's second law, and 4 equals ma and 8 equals ma. So the total force, so the total acceleration of this object constitutes of the total force. So due to this total force, the object travels in the direction of the net force. So the resultant force that can replace all these forces is that since these are in the same direction, what you can say is that we should take the addition, because this is actually a vector addition. Because force is a vector, we have to take the vector addition. So the total force for this system experienced by system is 15 Newtons. So the acceleration and the other things, all the other behavioral changes that happen on this system is analogous to the same 15 Newton force as provided by these 3 Newton, 4 Newton and the 8 Newton forces. However, when this 8 Newton is reversed in this direction, what generally happens is that we have to take the vector addition. So when you take the vector addition, now you know that if we have some force in this direction, we have to generally take the minus value, because this is in the direction of the actually in the opposite direction to which we are considering. So if we take the positive direction in this direction, this 8 Newton will be minus. So the total force in this direction will be 3 plus 4 Newtons, which is 7 Newtons, and the total force in this direction is 8 Newtons. So the total force of this system, the total force felt by this system is minus 1 Newton. So the value of minus 1 Newton in this direction is the same as 1 Newton in this direction. So when forces are not in the same direction, their vector should be considered, and if the forces are in the same direction, you can even ignore the vector quality of force, you can even take only the magnitude. But it's always better to remember that since force is a vector, you should take the vector addition. Alright. So if another important relationship of not a relationship, in another important occasion where the resultant forces come into play is the occurrence of inclined forces on a system. Now when you have some inclined force like this 8 Newton, which makes a 60-degree angle with the horizontal, what generally happens is that this creates some force in this direction as well as this creates some force in this direction. So actually I explained to you about the decomposition of forces in one of my previous videos. So due to that reason, this object tends to move in this direction as well as in this direction. Now I have already applied two forces of magnitude 5 Newton and 6 Newton in this direction, so they will also have an effect on this system. So what you have to do here is that if we are to find the resultant, unlike in the case of finding the moment as I explained in the last video, the only left step that we can take is to decompose the forces. So in the case of moment, I explained to you that there are two methods to find the moment of an inclined force. One method is to find the force, you already know the magnitude, and in the first method it included that we have to find the perpendicular distance to that inclined force to the point where we take the moment. And the second method was to decompose the forces in the horizontal and the vertical direction in some plane and then take the moment around that point. But although there were two options that were available when taking the moment, there is only one option that is available when taking the resultant of a force. So in this case, what we do here is that we have to decompose the force in the horizontal and the vertical directions. So actually this horizontal and vertical direction, or the horizontal and the vertical components of an inclined force, is actually not necessary in the case of decomposition of forces. You can decompose in any two perpendicular directions. If this force is 75 degrees, you can even decompose in some direction so that they are perpendicular to each other. So the general procedure includes that we are decomposing these forces either both in the horizontal and the vertical directions. So so in the case of inclined forces, what generally happens is that we have to decompose these forces. So I'll decompose this 8 Newton force in this direction. So this angle is 60 degrees. So the force component in this direction will be 8 cos 60 newtons, and the force in this direction will be 8 sin 60 newtons. So the total force in this direction is 5 newtons plus 6 newtons plus 8 cos 60, which is 4 newtons. So the total force in this direction will be 15 newtons. You also have a force in this direction which is 8 sin 60. So sin 60 is root 3 over 2. So the sum of forces, since this is the only force that is available in this direction, the sum of forces in the vertical direction is 8 sin 60. So you know that Ry is now 4 root 3 newtons and Rx is 15 newtons. So as I mentioned in my videos on vector decomposition and finding the resultant, what you can do here is that to find the resultant, you have to square these terms individually. Right? Now we want to find the single force which can stand along from the effect of these two forces. And it should be clear that if an inclined force is given, it should be divided into its horizontal and vertical components, and the resultant should be calculated. Conversely, horizontal and vertical forces can be reduced to another inclined force which can stand out with the same effect produced by the two individual and perpendicular forces. Thus, the product above can be simplified into a relationship like this. So this is 4 root 3 newtons, this is 15 newtons. So what generally happens is that this is actually a Pythagoras triangle here, right angle triangle, in which we can apply Pythagoras theorem. So the resultant force is calculated by squaring the individual horizontal and the vertical or the perpendicular forces, and finally we get that to be 16.52 newtons, and it makes an angle of 24.79 with the horizontal. So that's it about finding the resultant force of a system. So another important characteristic of finding resultant forces is that we can join these two, the momentum that the moment of a force as I mentioned in my last video, with the described about the resultant force. So you can merge these two principles. One of the occasions where we can merge these two principles is the moment is the occasion in which we can produce the same effect of rotating or translating as produced by the whole system. So this system can be reduced to a system like this. So the total effect of this system can be reduced to the effect of the resultant force of this system. So the principle is that the total moment exerted by the individual forces around a point. So the total moment exerted by the individual forces around a point means, now say if you take a point A, you can say that since F5, F3 and F4 go through A, you can ignore their effect, and you have to take only into account about the moments created by F2 and F1. Similarly, if you take a point like D, since F5 and F1 go through D, you have to ignore the effects created by those two forces. So you have to actually consider only F3, F4 and F2 here. So you can take some points and you can see as to how the total moment of that system varies. So what generally happens is that we can reduce this whole system, since we have found the resultant of this system to be such a magnitude in such a direction. You can say that the total moment exerted by the individual forces around some point, say A, is equal to the moment exerted by the resultant of these forces around that point. So that should happen because this set of forces are in fact reduced to the resultant R. So the same effect is expected from the resultant R as well. So considering point A, you can say according to the principle, the moment of forces around A is equal to the moment of the resultant of these forces around A. So from the above principle, you can say that the moment of forces around A by the force system is, as we calculated in one of my in my last video, is F2D minus F1D, because F5, F3 and F4 go through A, so the effect can be ignored, and the only effect that happens, the only effect of the forces that create moment around A are F1 and F2. So F2 creates a moment around this point in this direction, clockwise direction, and F1 counterclockwise or anti-clockwise direction. Since the lengths are equal, since this is a square and those lengths are equal to D, you can say that the total moment created by F2 is F2 times this length D, or this length D, and minus F1 times this length or this length D. So the total moment created by the force system is F2D minus F1D. And when we actually, since this is an inclined force, what I'll do here is I'll decompose this force along the horizontal and the vertical directions. So when I decompose this force in the horizontal direction, that is equal to R cos alpha, but unfortunately that R cos alpha goes through A, so we have to ignore the effect created by that component. When we think about the other component, which is R sin alpha, that is perpendicular to here, this direction, and we have this length and it doesn't go through A, so some effect is created by that component. So if this length is x, you can say that R sin alpha times x is equal to the moment of the resultant of this force around A. So according to the principle, you can say that these two this part or the left hand side is equal to right hand side. So if you know the value of alpha and R, you can calculate the value of x. So let's do a simple problem in which we have some effect like that. So assume that we have a hexagon like this, and I think I'll consider this to be a regular hexagon of length 4 meters. So the forces as shown below, 4 newtons, 1 newton, 6 newton, 5 newton, 8 newton and 2 newton, act around these sides of the hexagon. So my question is, and my intention is, intention of this problem is to calculate the first of all the moment around points D and F, and then the resultant of the whole system, and the point where the resultant intersects the system. So the point where the resultant intersects the system can be found this way. So first of all, you need to find the moments around point D and F. So as the first step, what I'll do is that it's easy for me if I actually decompose these forces in the horizontal and vertical directions. So because I don't have to calculate the perpendicular distances individually, so I'll decompose all these inclined forces along the horizontal and the vertical directions, so the system can be expanded as follows. So I'll not explain about decomposing these forces here, because this is not about decomposing forces. I have explained those videos about those concepts in one of my previous videos on introductory to physics. So if you have not watched that video, I invite you to watch that video and come back, because I will not explain that here, because this is not about decomposing forces. I want to calculate the moment. So when I calculate the moment around point D, you can say that this 5 Newton force is the only force that goes through D, so you can ignore the effect of that and you can calculate the moment of these forces. So 8 cos 60 has an effect of now when I take the clockwise moment, 8 cos 60 actually makes a moment in this direction, because this is the force. It makes a moment around this direction, so that is anti-clockwise, so it will be minus. And 8 cos 60 is the force, and the perpendicular distance is this distance. So since this is 4 meters, you can calculate this distance to be 2 root 3. So that the moment created by 8 cos 60 is minus 8 cos 60 times 2 root 3. Similarly, 8 sin 60 actually rotates around D in a clockwise direction, so we are considering the clockwise moment. So we have to, since this is also moving in the clockwise direction, we have to add that. So the force is 8 sin 60. You can calculate this distance to be 2, right? So this is about geometry, calculating the perpendicular distances. So I'll not explain as to how they were calculated. You can calculate it now. This is 4 and this angle is 60, so this is 4 cos 60, this is 4, so 4 cos 60 is 2, so you can calculate like that. So finally you can say that the moment around this point is minus 5.62 Newton meters. So this minus 5.62 Newton meters indicate that the moment is in the counterclockwise direction, because if you get, now you know that the moment is actually a vector. So if you get a minus value for the moment, you have to change the direction. So I have considered the clockwise moment. So since we have obtained a minus value, you can say that the moment about point D is 5.62 Newton meters, but that is in the counterclockwise or anticlockwise direction. Similarly, you can calculate the counterclockwise moment about point F here. So when thinking about point F, this force, they are the only forces that go through F, and we can calculate the moments around point F like that. So this 5 Newton is in this direction, so it's making actually counterclockwise direction. So I'm taking the counterclockwise moment, right? So don't confuse with this. So here I have taken the clockwise moment, here I have taken the counterclockwise moment. So this force 5 newtons is making a moment around this point around F, so that's positive. And this 4 times 2 root 3 is, I think, this force. Yeah, this force is also making counterclockwise or anticlockwise moment around point F, so that's also positive. This 6 sin 60 is moving in this direction around this. When I take the moment around point F, it moves in this direction, so that is also counterclockwise. 1 sin 60 is this force, so when I take the moment around that force also moves in this direction. And finally 1 sin 60, sorry, this is 1 sin 60 makes a counterclockwise direction, 1 cos 60 also makes a counterclockwise direction. So all the moments is positive when I take the counterclockwise direction. So the counterclockwise moment around point F is 79.67 meters. So my second question is to find the resultant of the system. So to find the resultant of the system, as I mentioned, I calculated actually without finding the perpendicular distances due to two reasons. One of the reasons as to why I decompose these forces is that I don't have to calculate the perpendicular distances. I can easily calculate these vertical and the horizontal distances, but if I have some inclined forces, it's hard to take perpendicular distances like that. And on the other hand, by decomposing these forces, it would be easy for me to find the resultant as well, because I know to find the resultant of inclined forces, I have to decompose in the vertical and the horizontal directions. So if I decompose these forces at the beginning and then find the moments, so it will be easy for the moments, as well as it will be easy when finding the resultant forces as well. So here I think it's important to not calculate the perpendicular distances. It's easy if you can decompose and then follow the sum. So when I take the positive, or actually the horizontal direction, I can say that 4 is positive, so I'll take the positive direction to be along this side, along AB or ED. So 4 is positive, 1 cos 60 is positive. However, 6 cos 60 is this force, that is negative. 5 is negative because it is in this direction. 8 cos 60 is positive, it is in this direction. And 2 cos 60 is also negative because it is in this direction. So those are the only horizontal forces that are available in this system. So you can say that they simplify to 3.5 newtons. When I take the vertical forces, I will take that to be y. So I am taking x and y because I normally denote the Cartesian axis. So we normally take x-axis along the horizontal direction and y-axis along the vertical direction. So that's the reason as to why I have taken rx and ry. So when I take the vertical forces, I can say the vertical forces are all positive because all are in this direction. So they will be 2 sin 60, which is this force, 1 sin 60, 6 sin 60, and 8 sin 60. So 2 plus 1 is 3, 3 plus 6 is 9, 9 plus 8 is 17, 17 sin 60 is 14.72 newtons. So the resultant, as I mentioned a little while ago, is actually the summation of the individual squares of these terms, and we have to take the root of that. So r squared is equal to 3.5 squared, which is rx squared, and 14.72 squared, which is ry squared. So r squared is equal to this sum, and we have to take the positive root of that. So that I have calculated that as 15.13 newtons, and the angle it makes with the horizontal as 77 degrees. So actually this angle was not asked by the question here, only the resultant of the system, but I have calculated that angle because I need that for the last sum I need to solve. So to find the resultant, where the resultant intersects the system, I can say that the total moment of forces around A, some point A or even B, C or any point, right? So I need to only know about where it intersects, not the moment around point. So I'll take the moment around A. So I can say that the total moment of these forces for system around A is equal to the moment that is created by the resultant around A. So this resultant is 15.13 newtons, and this angle is alpha, so this is the same as this one. So actually, if I was not asked to find the value of r here, I don't have to calculate r, because in any case I'm going to decompose these forces in the horizontal and the vertical directions. So if I know the values of rx and ry, you know that r cos alpha is rx and r sin alpha is ry. So r cos alpha goes through A, so I can ignore that effect. R sin alpha, it doesn't go through A, so r sin alpha creates some moment around A. So I know that r sin alpha is actually ry. So if I was not asked to find the value of r here, I don't have to calculate that, because if I know the value of ry, I can calculate the distance where this r value intersects this system. So r sin alpha is actually I have found that to be 14.72 newtons, and that is equal to ry, and that multiplied by x should be equal to actually should be equal to 5.62 newton meters. So solving this, we can get that x is equal to 2.03 meters. Sometimes in some quizzes you can say that x can be negative. So I have measured x from A to B in this direction. So if x is negative by chance, what you can say is that the resultant intersects the force system negative or left to that of A. So I am measuring the direction, the distance direction is from A to B. So if x is negative, I can say that the direction in which, or the distance or the point where the resultant force intersects this system is left to that of A. Alright, so that's it about the resultant of forces. So in the next video I'll be talking about some other concepts of mechanics, center of mass and equilibrium. So thanks for watching this video, and see you then.